Good day, everyone. Here we go again. Teacher Josie is back to discuss to you about rational number. Rational numbers are numbers that can be written in the form of A divided by B, where A and B are integers and B is not equal to 0. So, if the numbers that can be written in the form of fraction and the denominator is not equal to 0, therefore that number is called rational number. Then we have subsets of rational numbers. Subsets of rational numbers are integers, whole numbers, and natural numbers. From here, as you can see, natural numbers belong to the set of whole numbers, belongs to the set of integers, and set of integers called rational numbers. What are natural numbers? Natural numbers are counting numbers. Those are the numbers that we use to count. That we are using in counting. So that those are 1, 2, 3, 4, 5, 6, and so on. So the set of counting numbers, those are called natural numbers. And those natural numbers can be found in the set of whole numbers because whole numbers are counting numbers including 0. So again, whole numbers are counting numbers including 0. So we have here the set containing 0, 1, 2, 3, 4, and so on. So another is we have integers. Integers, natural numbers, whole numbers belongs to integers. What are integers? Integers are whole numbers and they are negatives. So, as you can see here, it is the set containing the whole numbers, whole numbers from 0 and negative. So, we have here this one. So, all of these are called rational numbers. So, let's take a look here. Expressing fraction to decimal form. Any rational number that can be changed from fraction form to decimal form. So any rational number can be changed from fractional form to decimal form. So again, any rational number can be changed from fractional form to decimal form. And this is done by simply dividing the numerator by the denominator. So fraction is part of a whole and decimal is a number based on the number 10 that contains decimal point. So how are we going to express fraction to decimal or in decimal form? So here are some examples. We have proper fractions. Why do we call this as proper fractions? Proper fractions because the numerator is less than the denominator, or the numerator is smaller than the denominator. So that's why it is called proper fractions. But how are we going to express fraction to decimal form? Or how are we going to convert fraction to decimal form? So number 1, we have 3/5. 3/5. So that is by simply dividing the numerator by the denominator. So that's why we have here dividing 3 divided by 5, then so this is just a process, the same process when you are taking it during your elementary school. So if you have smaller number as the dividend and dividing it to the divisor, a bigger number divisor, you just add decimal point and add 0. Add 0. So this will become now 30 divided by 5, then you have 0.6. So the same process here. So we have here 4 over 5. So 4 divided by 5 cannot be, so that's why we have 0. And since this is smaller than this one, so we will add the decimal point and add 0 so that you can divide this one by 5. So we have here 4 divided by 5 is 0. 0 times 5 is 0. Subtracting, we have 4. Bring down 0. So that will become 40 divided by 5 is 8. 8 times 5 is 40. Therefore, 4/5 is equivalent to 0.8. Okay, 0.8. Number 3, 6 divided by 8. So your divisor is 8. This one, okay, correction, this must be 8. 6 divided by 8 cannot be, so that's why we have 0. 0 times 8, this is 8. Correction please, this is 8. 0 times 8 is 0. Then minus, you still have 6. And add decimal point, okay, same as in the quotient. So then add 0 and bring down 0. So you have here 60 divided by 8 is 7 because 7 times 8 is 56. So this must be also 56. This is just a typographical error. So this is 56. Then 60 minus 56 is 4. Bring down again 0 or add 0 here and bring down 0. That is 40 divided by 8 is 5. So 5 times 8 is 40. Then you have 0. So therefore, you have here 6 over 8 is 0.75. Then improper fraction. For number 4, we have improper fraction. Improper fraction because the numerator is greater than the denominator. That's why it is called improper fraction. So 8 divided by 5 is 1. 1 times 5 is 5. So minus, subtracting, we have 3. Then since 3 is smaller than 5, then we will add 0. But do not forget the decimal point to indicate there before the 0. So before adding 0, you have to indicate the decimal point in line with also in the quotient. Okay, so bring down 0 divided by 5 is 6. 6 times 5 is 30. Then that is subtracting, that is 0. So therefore 8 over 5 is 1.6. Next we have non-terminating repeating decimal. So 5 divided by 9. So 5 divided by 9 is, cannot be. So therefore you have 0. 0 times 9 is 0. 5 minus 0 is 5. We will add again decimal point. When you add decimal point here, you have to add decimal point also in the quotient. Then add 0, bring down 0, therefore it is already 50. 50 divided by 9 is 5. 5 times 9 is 45. 50 minus 45 is 5. Bring down again, add 0 there and bring down 0. Again, you will have 50 divided by 9 is 5. Then again 45, subtracting, we have 5. Then if you will add again 0, this will become 50 again. Then again, divided by 9 is 5 again. Then this is 45 again, so subtracting, then it is repeating. If you will continue that one by adding 0 here, it will just be 5, 5, 5, 5, 5, 5, 5, 5, and so on. So therefore, It is non-terminating but repeating decimal. Number 6, we have negative 1/5. Negative 1/5. So we have there negative 1 divided by 5. Negative 1 divided by 5 is 0. Okay, 0 times 5 is 0. So bring down negative 1, and we will add 0. So decimal point, do not forget, but you have to add 0 and bring down 0. So that will become negative 10. Divided by 5 is negative 2. So negative 2 times 5 is negative 10, but since we have subtraction here, subtracting we have here, so this will become positive here because it will change the sign here, and that is cancelled out. Therefore, negative 1/5 is equal to negative 0.2. Okay, that is for negative fraction. Then, how are we going to express decimal to fraction form? So a decimal is changed to a fraction by using its digits without the decimal point as the numerator and selecting an appropriate power of 10 as the denominator. So the fraction can be changed to lowest term when possible. So we have here, under decimal, we have terminating decimal. So a decimal number that has finite or finite number of digits. Okay, so that is terminating decimal. So that is a decimal number that has limit numbers of digits, or a decimal number that ends up with a remainder of 0. Okay, for non-terminating decimal, these are decimal numbers that has no end, which can be repeating or non-repeating. So if that is repeating decimal, okay, repeating decimal is a non-terminating decimal with repeating pattern. So like for example here, 0.3, if you have the bar there, it means the 3 is repeating and it is non-terminating. So it means it is continuous. So that is just equal to 0.3333333 and so on. So another example here is 0.352. So the bar is at 352. So it means that the 3 digits are repeating. So that is 0.352, 352, 352, 352, and so on. Another we have here 0.75, and the bar is only at 5. So therefore the repeating digit is only 5. So that is 0.7555555555. So only the 5 is repeating. In another one, okay, 0.2394. So the bar is only at 94. So therefore, it is just equal to 0.3, 94, 94, 94, 94, 94, 94, 94, 94, and so on, because it is non-terminating decimal. Next one is 2.3, and the bar is at 3. So therefore, you can also write this as 2.3333333, and so on. So that is for repeating decimal but non-terminating decimal. Next one is non-repeating decimal. It is a non-terminating decimal with no repeating pattern. And it is irrational number. Like for example here, there's no bar. You cannot find a bar here. So that is, for example, the value of pi. Pi is 3.14159265359, and so on. We don't know what is next because there's no number which is repeating here. Okay, so no number repeated here. So you don't know what are the numbers here, but it is continuous. It is non-terminating. So therefore, this kind of number is called irrational number. Okay, so here are some steps in converting decimal to fraction. So our given is 0.25. So the number 2 step is to change the decimal into fraction form by using the decimal number as the numerator and put 1 as the denominator. So the decimal number, okay, that is 0.25 as the numerator and 1 as the denominator. Number 2, move the decimal point of the numerator to the right until it becomes a whole number. So move this decimal point after the number. So how many times you're going to move? 1, 2. So that will become 25, then point. So if the decimal point is already after the number, therefore it is already a whole number. How many places you're going to move to the right? That is 2 places. Therefore, since you have 1 there, you have to put 1 as the denominator, then you will just add 2, 0. And that is 25 over 100. And 25 over 100, 25 and 100 rather, have common factors, which is 25. So reducing this fraction using its greatest common factor, therefore we have 1/4. That's it. That's method 1. For method 2, we have here word form. Okay, so we will consider rather place value. Okay, place value 0.3. The place value of 3 is tenth. Okay, with ph, tenths. So therefore, it is okay. You can read this as 3 tenths, and you can write that tenth as over 10. So you have 3 and over 10. Here, you have to consider the last digit, the last number. What is the place value of the last number? And that is hundredths with ph. So 25 hundredths. And you can write that as 25 over 100. When you have th on the last, okay, th, therefore this one is on the denominator. So next is 1.354 1 and 354 thousandths. So we have 1, okay, and 354 over 1,000. And 354 over 1,000 can still be reduced by 2, okay, can still be divided by 2, and that is 177 over 500. But the 1, we just rewrite the 1, okay. So you can also use the word form, which is the place value of the number, or you can also use the method 1, that is putting 1 and then moving the decimal point to the right. If you move the decimal point to the right by 2 places, then you will add 2 zeros. If you move it to the right by 3 places to make it a whole number, therefore you will add 3 zeros on the denominator. That is the method 1, then this is the method 2. Okay, here are examples. Okay, here. The place value of this, number 1, we have 0.9. The place value of this is tenth, and that is 10 on the denominator. if you will consider the first method, you will write 1 here. Then you will write here 0.9. 0.9, you move 1 to make it whole number. If you move 1, that will become 9. And you will add 1 0 because you only move one place to the right. Here, 1, we have whole number. The whole number is not included here. So you will just rewrite the whole number. Okay, rewrite the whole number. But 2, okay, the decimal part there is 0.2. Move 1, so that will become 2. Since you move 1, you will add 0 on 1 here. Okay, but this one can still be reduced by 2. And that is dividing by 2, both numerator and denominator, and that will become 1/5. So we have the whole number 1, and this side here is 1/5. Next, we have number or letter C, or number 3, 4.25. So again, rewrite the 4 there. This 0.25 is the decimal number. So move 2 places to the right, that will become 25. Then you write 1. How many places you move to the right? 2 places. Then you will add 2 zeros. But since they can still, or both numerator and denominator can still be reduced, and that is dividing by the greatest common factor, which is 25. So therefore we have 1, and 100 divided by 25 is 4, retaining the whole number 4. So the same process here, retaining the whole number 1 there, and 375 can be written as 375 over 1. Since you move 3 places to the right, then you will add 3 zeros here. And 375 over 1000 can still be reduced by its greatest common factor, which is 125. Therefore, we have 375 divided by 125 is 3. 1000 divided by 125 is 8. So therefore, 1.375 is also equal to 1 and 3, 8. That is for converting decimal to fraction. Another. In converting non-terminal repeating decimal to fraction form, we will use the formula below. We had the repeated terms and the number of 9 for the repeated terms. Okay, number of 9 for the repeated terms. What is our given? 0.3. It means 3 is repeating. Okay, so the repeated term is 3. So we have here given 0.3. What is our repeated term? 3. Since there is only one repeating term, we will have 1 9 in the denominator. So since only one number repeating, so therefore we will have only 1 9 in the denominator, and that is 3 over 9. But you can still reduce this one, which is 1/3. Okay, next. How many terms repeated? There are 3, that is 3, 5, 2. Since there are 3 repeating terms, then we will have 3 9s in the denominator, and that is 352 over 999. So there are 3 repeated numbers, therefore there are also 3 of 9. Here we have the repeated term is 7. So since there is only one repeating term, so we will have 1 9 in the denominator. So we have here 5 plus 0.7. So we have 5 plus 7 over 9. So only one term is repeated. So we have only 1 9, and that is 5 and 7 over 9. Then converting that one, so we have multiplying 45 plus 7 is 52 over 9. That is in improper fraction with 1 9 because only one number is repeating, so therefore only 1 9. Next one. In converting non-terminating repeating non-terminating but repeating decimal with non-repeating and repeating term to fraction form. Again, non-terminating repeating decimal with non-repeating and repeating term to fraction form. So here, to find or to convert that to fraction, we have to get all the terms after decimal point. Okay, all the terms after decimal point minus non-repeating terms divided by the number of nines for the repeated terms and the number of 0 for non-repeating terms. Okay, for example, 0.75. The only repeating term is 5. So only one number or term is repeating. So what are the terms after decimal point? So the term after decimal point is 75. So there are, okay, 2. And non-repeating, because it says here non-repeating term. The non-repeating term there is 7. Since there is only one repeating term, okay, for one repeating term, for the repeated term, you have to write 9. So since we have only one repeated term, therefore you have only 1 9. Okay, next one. Another is for the number of zeros for non-repeating terms. So since there is only one non-repeating term, so we will only have 1 0. So again, this is the number after decimal, which is 75, minus the non-repeated term, non-repeating term. So 7 is the non-repeating term over 1 repeated term and 1 non-repeated term. So for the repeated term, you have to write 9. For the non-repeated term, you have to write 0. Okay, and that will become 60. 75 minus 7 is 68 over 90 or 34 over 45. So we will have another example, number 2 example, 0.23594. So the repeating term is only 94. So 2 numbers repeating. So what is the number, or what are the terms after decimal point? So the term after decimal point is 23594. These are the term after decimal point. What are the non-repeating terms? Non-repeating terms. So non-repeating terms, ito yung hindi nagre-repeat. Okay, these are the non-repeating terms, 235. Since there are 2 repeating terms, therefore you have also 2 nines. Okay, and since there are 3 non-repeating terms, therefore you have 3 zeros in the denominator. So we have the formula. These are the numbers after the decimal point minus the non-repeated term. Okay, non-repeated over, there are 2 numbers repeating, which is 94, 94, 94, 94. So there are also 2 nines. And there are 3 numbers, non-repeated numbers. And that is 2, 3, 5. So there are also 3 zeros. 23,594 minus 235 is 23,359 over 99,000. So that's it. So we have here the activity, that is fraction form and decimal form. We have the decimal form here and transform that to fraction. Then we have another decimal, transform to fraction. Then we have fraction, transform to decimal. Then this one, decimal, transform to fraction, fraction to decimal, then fraction to decimal. Since we already discussed the rules earlier, then you will just review the rules and you can now answer this one. Okay, so that's all for today. So again, we will go back to rational numbers. Rational numbers are numbers that can be written in the form of a over b, where a and b are integers and b is not equal to 0. So again, to convert rational number from fraction to decimal, simply divide the numerator by the denominator. So to convert terminating decimal to fraction form, follow the steps below. So we have here number 1, change the decimal into fraction form by using the decimal number as the numerator and put 1 as the denominator. Then number 2, move the decimal point of the numerator to the right until it becomes a whole number. Then move the decimal point of the denominator to the right by the same number of places that the decimal point of the number moved. So place a 0 if the decimal point have moved to a decimal place without digit. Number 4, we have reduce the fraction into lowest term. Then we have another one, to convert non-terminating repeating decimal to fraction form, use the formula. We have here repeated terms over number of 9s for the repeated terms. So repeated terms. Then to convert non-terminating repeating decimal with non-repeating term and repeating terms to fraction form, use the formula below. So we have all terms after decimal minus non-repeating terms, then number of 9s for the repeated terms and number of zeros for non-repeated terms. So that's all for today. I hope you learned something from me, and please subscribe my YouTube channel. Thank you so much and see you next video. Have a great night or have a great day ahead.